Hey folks, welcome to this episode on isotopic calculations. All right, here we are doing another example where we are going to have to find the mass of an isotope. Here we are given three isotopes, neon 20, neon 21, and neon 22, and we have to find the unknown mass of neon 21. We have that little blank here in the question. So it says that neon has three isotopes, and we need to determine the mass of neon 21 using this following information. All right, so we know that our equation is going to start us off. We know that our average mass is equal to the percentage of neon 20 times the mass of neon 20 plus the percentage of neon 21 times the mass of 21 plus the percentage of 22 times the mass of 22. Okay, so we have all of these together. We are going to be looking for the mass of M21 or the mass of 21, or mass of neon 21. So I'm just going to highlight that just to draw my eye to that. All right, so what we want to do is we are going to want to manipulate this equation, get all the expressions on the other side, and manipulate for M21. So we can see that everything, this expression here and this expression here is just being added to this one over here. So we can actually move that to the other side and change the operator. So I'm going to rewrite that as the average mass minus the percent of 20 times the mass of 20. And again, minus the percent of 22 times the mass of 22. Okay? And that's going to be equal to the percent of 21 times the mass of 21. We can get rid of all these brackets since it's now already isolated. The next step is trying to get M21 by itself. And right now it's multiplying by the percent of 21. And so the easy way of getting rid of that is dividing both sides by the percent of 21. Okay, so percent of 21, percent of 21. These will cancel out, and that means we can get rid of them altogether, and we are now solving for M21. Okay, so it's not that difficult, especially since we have brackets. We can move those expressions together, just change the operator, and then isolate for M21. So now we're in a good place to start plugging in our values. Our values are, now, we don't have an average mass for neon. Remember from our last video where that is found. That's found from our periodic table. So neon has an average mass of 20.18 AMU. So that's an easy find. So if you're ever looking for an unknown and that unknown is an average mass, that is always going to be found on the periodic table. The other thing that we have to do before we start is that we have to convert these percentages into decimals. So this will be 0.904800. This over here will be 0.002700. And this over here will be 0.092500. Alrighty. Next, we have everything that we need. Let's get started. Let's start putting everything into here. And our average mass will be 20.18 AMU minus. So our percentage of 20 is 0.904800 AMU. Excuse me, not AMU, just a percentage. And then our mass of that 20 is 19.9924 now is the AMU. Alrighty. Next, our percentage of 22. That's going to be 0.092500 times the mass of 22, which will be 21.9914 AMU. Alrighty. And then we divide this whole thing by the percentage of 21, which we found out to be 0.002700. Okay, so now what we want to do is we want to get all the expressions in the brackets done first, and then we can do everything in order from there. So I'm just going to write this down, 20.18 AMU minus. Now, we're going to do this multiplication within the bracket, and we're going to keep that AMU because we're just multiplying by a decimal. And this is going to be 18.0891 AMU minus, again, the next expression, we will have 2.03486 AMU, all divided by 0.002700. 0.700. Okay, so now all of the units are in the same unit. We can subtract everything. And what we are going to get is we are going to get 0.05604 AMU, all divided by 0.002700. Okay, perfect. If we divide this through, our final answer is going to be 20.67896 AMU. Alrighty, and that's it. These are our calculations. You can change these into significant figures. For example, 20.68 AMU. So remember that this is the mass of 21. This is what we were solving for before. So neon 21, that is what we're solving there. We have found that that mass is 20.68 AMU. And does that make sense? It does, because typically we round these numbers, these AMU numbers, into the nearest whole number. So if we were to round this up, we round it to 21, which again is the mass of neon 21. All right, so just a recap. First things first is that we recognize that we are looking for the mass because there was a blank there, and we set up our equation. We noticed that we were missing something. That thing that we were missing was the average mass, which we found on the periodic table. We rearranged our equation, and if you need a little bit of help with that, you can rewatch that part of the video a couple times just to see how we did that. And plugged everything in, kept our units consistent, and then got our final answer as seen below. I hope you found this helpful. Please like, subscribe, and hit the bell notification for future uploads. I really appreciate you being here. Please share this with your friends that are also struggling with some chemistry, and we'll see you on the next one. Have a nice one.